Unit 1, Foundations in Geometry, Lesson 1-3, Midpoint and Distance. Here are the objectives. Use the midpoint formula to find the midpoint of a segment drawn on a coordinate plane, and use the distance formula to find the length of a segment drawn on a coordinate plane. Midpoint of a segment. The midpoint of a segment is a point that divides a segment into two congruent segments. Right there are the markings. We discussed that in lesson 1-2 as well. Those slash marks are telling us that segment AB is congruent to segment BC. A line, ray, or segment that intersects a segment at its midpoint is said to bisect the segment and is called a segment bisector. So line L up in that diagram is a segment bisector. In the diagram above, B is the midpoint of segment AC, and line L is a segment bisector of segment AC. Midpoint formula for a number line. It's the point in the middle of a segment, like point M right there. Here is the formula. If segment AB has endpoints of x1 and x2, those are going to be numbers on the number line, then the midpoint M of segment AB has coordinates is just the average of those two coordinates. And we would add them up, add the two numbers up, and divide by 2. And that would give us a point such that segment AM is congruent to segment MB. Let's find the midpoint of segment QR. We are given coordinates for Q and R. The midpoint is the average, so we add them up. 4 plus -3 divided by 2. Be careful if you're putting it in the calculator. You need to get that sum on top before you do the divide by 2. So you can't just type it straight in. So be careful with that. So that's 1/2 or 0.5, and there it is on the number line. Now we're doing it in a coordinate plane. It's the same idea. It's the midpoint of the x's and the midpoint of the y's combined. So if segment PQ has endpoints at P, x sub 1, y sub 1, those are not exponents, those are subscripts, and Q has coordinates x sub 2, y sub 2 in the coordinate plane, then the midpoint of segment PQ has these coordinates. So you add the x's, divide by 2, add the y's, and divide by 2. And that is a point. So you should have parentheses and a comma in between. Find the midpoint of segment AB. There's a reminder of our formula for midpoint. So I like to just put down the structure first. I know it's going to be a point, so I'm using parentheses. It has two coordinates, so add a comma. We're going to be adding and dividing by 2 for both the x's and the y's, and I just put down that structure first before I put any numbers in. And then grab the x's. So the x's in the 2 points are -3 and 4, and the y's and the 2 points are 2 and -2. Plug it into your formula and simplify. We get 1/2 and 0/2, which of course is just 0. So the midpoint of segment AB is the point 1/2 or 0.5, either way, comma 0. Here's some practice. Find the midpoint of segment GH, and we have our coordinates there. Remember, there's our formula for the midpoint. So we're going to add the x's, divide by 2, add the y's, divide by 2. We get 16/2 and -6/2, and our midpoint is at the point 8, -3. Let's find the midpoint of segment AB, and we have the coordinates of both A and B. We need to average up the x's and average up the y's, so the x's were -7 and 3. Add those up. We're going to divide by 2, and the y's are 4 and -4. Add those up and divide by 2. Let's simplify. We get -4/2, 0/2. Negative 4 over 2 is negative 2, and of course 0 over anything is 0. So our midpoint is at the point negative 2, 0. This is what it looks like in delta math. Okay, nothing really different than what we've already done. They give us the coordinates. We're finding the midpoint. There's our formula just as a reminder. So we add our x's, divide by 2, add the y's, divide by 2. Simplify. We're going to get 3 halves, or you could put 1.5. I think they accept it either way. And then 6 divided by 2 is 3. They do have a calculator option off to the side. There's a little symbol for it, and if you press that, that comes up. And your answer is going to go in an answer box. You type in a parenthesis. If you do 3 and then /2, it'll come up as a fraction there for you. You will need to type in the comma and then the 3 and end your parentheses. Different type of problem. We're going to find the coordinates of A. M is the midpoint. Okay, so it's different. We're not finding the midpoint. We're given the midpoint. We have one endpoint, B, at the point 3, negative 5, and we have to find the other one. We can calculate. So we know the midpoint has an x value of negative 1. So negative 1 must be the average of whatever the x is for A, and the 3, and divide by 2. Let's see, we can calculate x is negative 5. We could do the same thing for the y's. We know that the midpoint y value is 2. We don't know one of them, so I put a y there. The one we do know for point B is negative 5. So calculate, so multiply both sides by 2. We get 4 equals y minus 5. Add 5 to both sides. Y is 9. We could also look for a pattern. So how do we go from 3 to negative 1? We went down 4. If we do the same thing, we end up at negative 5 on the right-hand side. To go from negative 5 to 2, we actually add 7, or we go up 7, do the same thing again, and we're at 9. So you can do it either way. It's generally not going to be set up like the way I set it up on the right-hand side, but feel free to do that. I think it is a lot simpler to do. Same kind of question. They give us the midpoint, and we need to find the other endpoint. We can calculate the x value for the midpoint's negative 5. The x value of the one we know is negative 8, so we're averaging some kind of x with a negative 8. We're going to multiply both sides by 2 and add 8 to both sides. We're going to end up with negative 2. Do the same kind of thing with the y. We know the midpoint, y value is 10. The endpoint they give us, the y value is 6. So we're going to be averaging that with some y. And plugging it in, we get that. Multiply both sides by 2 and subtract 6 on both sides, we get 14. Doing it the other way, I do have it all lined up over there. To go from L to K, the x's, we're going from negative 8 to negative 5. We went up 3, do the same thing. We're at negative 2, it checks out. Go from 6 to 10, we're adding 4. If we add 4 again, we're at 14. So we're right back to where we were when we did it the algebraic way. Here we go. Now, it is a problem in delta math. They give us the midpoint of the segment. They give coordinates for one of the points. I have my structure written down there. You might want to jot that down on paper, possibly, if that helps you. Instead of doing it all algebraically, but you do need to set it up correctly. A could be on the bottom or the top, does not matter. So if we're going from negative 5 to negative 3, we're going up 2, do it again, and we're going to be at negative 1. If we go on the y side, 1 to 4, we're going up 3, do it again, and we're going to be at 7. So our other coordinate for B is negative 1, 7. A little bit different. We do know midpoint divides a segment into two congruent segments, and now we're doing algebra. So we need to set those two equal to each other. So 7x minus 16 equals 4x plus 2. We have x's on both sides this time. We're going to move the smallest one. So we're going to subtract 4x on both sides. We get 3x minus 16 equals 2. Next thing to get rid of is that minus 16. We do the opposite. So add 16 to both sides. We get 3x equals 18. When you divide both sides by 3, x is 6. The next one we have to do a step more than what we did. It says if h is the midpoint, so we do know those two algebraic expressions are equal to each other, but this time we need to find the length of segment GH. So we have to find x first, and then we're going to plug it back in. So 5x plus 2 is equal to 9x minus 10. Subtract the smaller x from both sides, because we do have them on both sides this time. So subtract 5x on both sides. Left-hand side is left with 2. 9x minus 5x is 4x. Bring down your minus 10. Get rid of the minus 10 by adding 10 to both sides, and then divide both sides by 4. We get x is 3, but we're not done. We need to find the length of segment GH. We have an algebraic expression for it. It's 5x plus 2, and we know 3. So we're going to plug 3 in place of x, and we get our answer of 17. Distance formula for 2 points in the coordinate plane is this expression. We are finding the difference in the x's and squaring it, plus the difference of the y's and squaring it, and we're taking the square root of that whole thing. Here we go. This is using Desmos. We'll get to that in a minute. We're going to find the distance between the 2 points, and they are graphed. But we need to find the coordinates for the points. I have those listed there. Probably helpful if they're not already labeled to write them down. So you have the coordinates for them. Writing down the x sub 1, y sub 1, x sub 2, y sub 2 is not that crucial. We have our formula there, and now we need to plug all of our values in. And technically, it doesn't matter which point has the subscripts of 2 and which one has the subscripts of 1, but just stay consistent. So let's see. Negative 2 minus negative 5. We're going to do that and square it. Plus, subtracting our y's. Negative 3 minus 3. I simplified that. Negative 2 minus negative 5. Remember, on the graphing calculator, negative and minus looks different, so be careful with that. So we get 3 squared plus negative 6 squared. When you square a negative, you do get a positive, so be careful that you're putting it in the calculator correctly. You should not have the square root of a negative number. You don't get to that until Algebra 2 when you deal with imaginary numbers. Okay, let's combine those. It's the square root of 45. I put in the graphing calculator square root of 45, and I got, let's see, directions say round to the nearest hundredth, so that's 2 decimal places. If you put it in Desmos, you can type that thing straight in. Excuse me. They want you to put the negatives in parentheses. So when you put in negative 5, put the whole thing in parentheses. When you put in negative 2, put it in parentheses. Same thing with the negative 3. And you can see the answer there. It just comes up on the right. And our answer is approximately 6.7. Let's do a couple more. We're going to find the length of segment AB. It's not graphed, but they give us the coordinates. It is to the nearest hundredth again. And there's our formula, just as a reminder. Let's plug our values in. We can say which point is which. You don't have to jot that down if you don't want to. You could do arrows doing one x minus the other x. If That helps you. And then the y's, but keep the x's together and keep the y's together. Common error is to not do that. So 3 minus -4, we're going to have to square that, plus -1 minus 1. Remember, there is a minus in the formula. And then a plus in between the two sets of parentheses there. I simplified. And kept simplifying. It's the square root of 53. Put it in the graphing calculator, or you could go straight to Desmos and it'll go a lot faster. And it's 7.28. Next problem, find the length of segment EF. I give you the 2 points. I threw in the little formula again and denoted which ones were going to be my first point and my second point. But once again, doesn't matter. 11 minus -7, we have that whole thing, we're going to square it, plus 3 minus -2, square it, and we're going to do the square root of that whole thing. I simplified that. Got the square root of 349, put it in the calculator. It's about 18.68.